So in this video, we're going to talk about the Nernst equation. And the Nernst equation sounds really scary, but I promise you it's something you've already built on. In fact, I've had a previous video that kind of starts the formatting for this. So go back and take a look on the video about the Gibbs relationship and finding the delta G if you're away from equilibrium. But we're going to derive the Nernst equation in 2 steps, and we're going to do it intuitively. And to do this, we're going to start with this relationship. Delta G equals delta G naught plus RT ln of Q. So Q here is our reaction coefficient, describes the ratio of the concentrations of the products and reactants at a non-equilibrium condition. We are not enforcing that Q has to equal KQ for this relationship. In fact, we don't want Q to equal KQ because the delta G is going to be 0. Your delta G naught is the free energy change based on the reference conditions. This is 1 atmosphere of pressure, room temperature, 1 molar for gases and mixtures, and whatever the concentrations of pure liquids and pure solids are. R, ideal gas constant, T is temperature. Now, the Nernst equation is how we're going to get the voltage of a battery. So, from the previous videos, the delta G here is in units of kilojoules per mole. So this whole relationship should give us kilojoules per mole. Now, the other thing to remember is that the delta G here is negative for a spontaneous reaction, but none of you have ever looked at a battery that said, oh, it's minus 9 volts. It's positive 9 volts. So we also need to not only change the units, but change the sign. We need reactions that are favorable to have a positive voltage. So the first step is to multiply this whole thing by a negative number. And what this negative number does, it says that if the delta G is negative, this is going to give us a positive voltage. We also need to be able to convert from kilojoules to volts. And so to do this, we have big F, and this is Faraday's constant. This is 96.485 volts per kilojoule times electrons. Now the other thing is you've never heard of a battery operating on a per mole basis. So what we've got here is N. And N is our number of electrons. It's basically taking our free energy and converting it from a per mole basis to a per electron basis. So if we do this multiplication, we get to step 1. Step 1 says that we have negative delta G over NF equals negative delta G naught over NF minus RT over NF ln of Q. That's step 1. What's step 2 to get the Nernst? Well, we're going to define a few things. Whereas before this was our reference free energy, we're now going to change this to V naught, and this is the reference voltage. This is the voltage assuming that we have 1 molar concentrations, 1 atmosphere, room temperature, so forth. Our delta G over NF here is going to become just our voltage. So we have 2 definitions here. V, our actual voltage, is the actual delta G over NF negative, and our reference voltage V naught is minus delta G naught over NF. And so what we get is that voltage equals V0 minus RT NF natural log of Q. And that is how we go from our starting expression for the delta G away from reference states to our voltage away from the reference states. It's just our delta G relationship times minus 1 over NF. And again, the whole point of this NF is to convert us from kilojoules to volts and from moles to electrons. And the whole point of this negative sign is to make sure that when we have a spontaneous reaction, instead of having a negative number, we end up with a positive voltage. And this is the Nernst equation.